Hi everybody, I'm Mr. Baird, and today we're going to be working on the measurement lab. We're going to move around and hopefully you'll be able to see each one. You're going to be making the measurements and I'm going to be following along on the data table. So you're required to make the measurements. I'm not going to tell you them. I'm just going to try to zoom in so you can see them for yourself. And then you should contact your teacher if you're having any issues about being able to see it or not. All right, so here we go. In Canvas, you should have a digital copy of the measurement lab, and you should be able to open it up into a Kami window. And the objectives for today, so I'm going to skip the I can statements down to the objectives. It says to become familiar with a variety of measuring devices, and also to be able to determine the uncertainty of measurement of various measuring devices as well. All right, so to determine your uncertainty, our typical rule is you're going to take half of the minor scale, or in other words, take the smallest mark and then divide that by 2, and whatever that is basically your window of measurement. Okay, and your individual teachers will go over that more in class. All right, so I'm going to go through the procedure and then really start at the data table. Okay, so the procedure says you're going to go to each station. Well, I'm going to do that for you. And then number 2, obviously we're not going to discuss it, so that at home you shouldn't be talking to each other online. You should just make your own measurements and then submit them through Kami onto Canvas. All right, so station 1 says take a piece of paper, and we're going to measure the length of a piece of paper using a centimeter ruler. So I'm going to move the camera and get that set up for you right now. Okay, folks, now we've come to the first station. The first station is a piece of printer paper using a centimeter ruler. Now, the first step when you're going to make a measurement is you want to know what unit you're using, what's the tool that you're using, and what unit is it measuring in. So if you look right here, okay, right there, you've got the centimeter mark. So I know that this is a centimeter ruler. We're always going to be in the metric system in science. So if you have a ruler that's got inches on the other side or something like that, you're going to ignore that. We're always using the metric system. Okay, so the first thing I want to make sure I got the piece of paper lined up right at the end of the ruler and really where the scale, the small mark starts. So I'm going to make sure that I get that lined up, and I do, so I'm not going to move it. The next step, once I've got my everything lined up, is to figure out what is my major scale. So on this ruler, your major scale is going to be the biggest line. So you can see we've got kind of little lines, we got medium-sized lines, and bigger lines. The biggest line represents your major scale. And in this case, if we go from big line to big line, it's only 1 centimeter, right? So if I go from 1 to 2, that's 1 centimeter distance there. All right, so my major scale on this one is going to be 1 centimeter each time. The next thing is I'm going to identify my minor scale. And you say, well, what about the one in the middle? The one in the middle is just really used for visual guidance, but typically we're going to ignore them. We look at the biggest and the smallest. So the smallest one, if you count, you've got 10 little lines, the smallest ones. 10 little lines there, that means that our minor scale is 0.1 centimeters. So 0.1 centimeter is our minor scale. Okay, so we're going to use both of those to make our final measurement. And because of the camera here, I can't show you the whole thing at once. We're going to have to slowly slide down, so hang on, we're going to slide. Okay, so we're getting down to the end of the white paper here. And we'll just make sure the camera's lined up. All right, so the camera is focused, and now you can see that we're at 28 centimeters. But that's a general measurement. It's not all of the information that this ruler can give us. We actually have to now take our minor scale and divide it by 2. So if you're taking notes, it's 0.1 divided by 2 will be 0.05. Okay, and I'm going to show you that written out in a second once we get this measurement done. So we're going to start out by writing 28, and then I need to now represent the minor scale. So I'm going to say 28.0 because it really goes right on the line of 28. So 28.00. So you say, why did you add 00? The 0 at the very end, or really the last two, the first one is for the minor scale, represents the minor scale, and then the next place value, that last 0, represents my uncertainty. All right, so we've got the ruler out of the way now, and we've written out the steps that I just described. So we started out by just identifying the unit, and we were in centimeters. Okay. Then we identified the major scale. We said each big line went up by 1 centimeter. The next was the minor scale, and the minor scale was 0.1 centimeters, or also the smallest little mark on our ruler. All right, then the next one is a little bit more difficult, and this is kind of the key to this whole process, is determining your uncertainty. So your uncertainty is you take your minor scale, or the smallest mark on your ruler, and you're going to divide it by 2, and that gave us 0.05 centimeters. All right, so let's look at the final measurement overall. Let me slide this up a little bit. Okay, so our final measurement can be written 28.00 centimeters. You say, well, where did these zeros come out at the end? Why don't we just say 28 centimeters and just leave it at that, no decimal points? The reason for that, the first 0, let me grab my pen here. The first 0 reflects the minor scale, right? So you're telling that you're telling your reader that when they look at your measurement, that you used a measuring device that can measure to this place value, right? And that was a mark on the ruler. So 28 centimeters comes from the ruler, straight reading off the ruler. My minor scale, again, comes from reading the smallest line on the ruler. But now we have another 0. And again, you might be a little confused and say, well, where does that one come from? That represents our place value for our uncertainty, right, down here. And this digit is going to be sometimes referred to as your estimated digit or estimated place value. So right here. Okay. So again, the 28 comes from the ruler. The 0 comes from the marks on the ruler again. But this place value, your last place value, is a place that you're going to estimate. Okay. Okay, so we've flipped over our little piece of paper here, and we're going to pretend like we were able to zoom in on our yellow ruler, and the green lines represent the scale of our ruler. So we have our major scale right here, the bigger line, the longer line, is 28 centimeters. And then we have our minor scale next to it, the little ones here. Okay, and then the red line represents the very edge of that paper, right? So 28 centimeters comes straight from the ruler. And then the minor scale, again, represents this little line here. So we have 28, or 27.9, or 28.1. And because our paper falls right on the line, we say, okay, 28, but you can't just leave it at that. You have to tell your reader that you have a minor scale. So we say 28.0. And now we also can estimate in between these lines. Let me get my pen here. Right? We can estimate in between these lines if we had to. So if the paper came to here, right, we could say, okay, we'd say 28.05 because we could estimate in between here. But we can't. The paper fell right at 28, so we say 28.0 to represent this line, and then 0 again to represent that we could estimate in between here if we had to, but in this case we don't. And in the next measurement, another one that I'm going to do for you, we'll make sure that there is an estimated spot so you understand that a little bit more clear. All right, thanks. All right, folks, so the next one you're going to be on your own. So we have a block of aluminum here. We've lined it up. Same ruler. And if you're looking at it straight on, the camera does a little bit of a trick to it, but we're going to slide you down. Right there. That should be good. Okay, and you can pause the video if you want. You make your measurement there. Make sure you go out to the right place value and include your uncertainty values. Major, minor, and uncertainty. All right, go. All right, so now we're down to station 3, and because this is our first volume measurement, I'm going to walk you through it. We have a graduated cylinder here, and we're not going to move it, but it does list milliliters at the top. So that's our first step, find our unit, so it does have milliliters on the top. The next step is to find our major scale, and the major scale, you can look, we have 15, and then it goes up to 20. So our difference is going to be 5 milliliters, right? From 15 to 20 is 5 milliliters. So that's our major scale, the biggest line. Then we have an intermediate line again. We're going to ignore that one. And then we have the smallest line, which is our minor scale. And our smallest minor scale line represents 0.5 milliliters. And if you want to take a minute to pause the video and count those lines in between, you can see how I figured out 0.5 milliliters. Okay, for a volume measurement, you're going to measure from the meniscus. And it is a bit hard to see on this graduated cylinder. That's why we're using this one as an example. And the ones that you're responsible for will be glass, so they're a little bit easier to read. But you really need to get down level. So if you were making this measurement in lab, you'd be bending your knees, getting down to be able to get eye level with the meniscus and reading straight on. Okay, and so we're going to pause the video here and then try to get a closer look at that. Okay, so we've gotten the camera a little bit closer here, and you can see, I'll try to do this without it focusing, but there's a bubble. Let me get my pen in here. So right here at the top, right there, there's a bubble. We don't want to look at the bubble. We want to measure a liquid from the lowest point, typically the meniscus. It's a little bit hard to see here, but it's between the two smallest marks, our minor scale. So if you look at starting at 15, you're reading up, right? We have 15, and then the next line is at 15 and a half, and then 16, and then 16 and a half. And then we're going to estimate in between there, right? So I'm going to make this measurement as about 16.8 milliliters. All right, now I'm going to break it down on a piece of paper so you can see where I got that measurement from. All right, the reason we picked this measurement to do with you is it's got a little bit of a tricky part to it. So the first part's pretty straightforward, but then the last part, the uncertainty, it's got a little trick that you're going to have to remember. Okay, so the first thing we did is we identified the unit. So that was milliliters. We got that off the top of the graduated cylinder. Then we identified the major scale, right? The biggest line, 5 milliliters. What's the difference between the two biggest lines, I should say? All right, next, the minor scale, or the littlest mark on our graduated cylinder, was representing 0.5 milliliters. And now for the uncertainty. So you take your minor scale, 0.5 milliliters, and you're going to divide it by 2, right? We talked about in our first video. All right, and then you come over here, you get 0.25. Now, the problem with this is that this 5 here is so small that there's really no way to make that measurement to actually see that place value. And so to get rid of that, we come up with the rule that your uncertainty always should have one significant figure, right? And hopefully you know what a significant figure is at this point. So we're going to round this up to 0.3 milliliters. Okay, so now we have one sig fig, right? That's one sig fig to 3. And we've gotten rid of that place value that was really too small for us actually to estimate. Okay, that really we couldn't tell the difference with the scale that we had, the minor scale that we had. All right, so let's put it all together. Your final measurement comes out to 16.8 milliliters, or 16.8 milliliters plus or minus 0.3 milliliters if you want to be really exact about it. Okay, so just remember, in this case, our minor scale place value and our uncertainty place value is actually the same place value, right? So this is a bit of a tricky spot. And in this case, we always have to just remember if you have one sig fig. So you're always going to be rounding up there to be able to get that one sig fig. All right, if you have any questions about this one, because it is tricky, I encourage you to reach out to your individual teachers. All right, folks, this is station 4 with a 100 milliliter graduated cylinder, and this is going to be all on you to make the measurement. So you want to pause the video you can and make your measurement on your lab. Okay, lastly here we have station 5. This is the last volume measurement with a graduated cylinder, and again, this is all on you. So please make sure you use all the tools we've talked about, and we can pause the video if you'd like to make your final measurement. Okay, this is station 6 now. We don't have a graduated cylinder anymore, but this is a beaker. You can see the scales are a bit different. Again, this is going to be on you now, though, to figure this out. Make sure that you round. Be careful there. And you can pause the video now to make your measurement. All right, now we're at station 7. I'm going to show you a little bit of the setup, but you're still going to make your own measurement here. And this is, I know it's a new tool, but we're going to challenge you. This is a quadruple beam balance. Quadruple is because it's got 4 little slides here that I'll show you at the top. And then you're going to mass material. You put it in here, then you can use this little guy to dump it if you need to. Okay. All right, so it asks you to mass a penny. Okay, so I'm going to put the penny on, but before I do, we're going to zoom in. So just, you're going to lose sight of down here, okay, but I am going to, not cheating you, putting the penny in here, okay, and then we're going to zoom in and show you how to use this mass scale thing. All right, so we've moved a little bit closer here, and now you can see we have the 4 beams that we're going to slide to counterbalance the mass of the penny. I haven't put the penny on yet. And if you look over here, you see a little white line and then a 0 mark. The pen. These need to line up, okay? And then notice, now keep your eye on that section. I put the penny on. Now the lines here no longer line up, okay? So we had to 0 the scale, and it was already 0 at the beginning. We had them lining up. And now we've put a mass on here, the mass of the penny, and it's thrown it off. So now I need to slide these slides to counterbalance it. So let me just, you start with the biggest one. That's too big, right? So it's all the way down now at the bottom. So that's too much. That's too much of a counterbalance. Okay, come back. All right, next one. Go down 1, click. Too big. Okay, so bring that back to 0. All right, next one down. Move that down. Ooh. Oh, not enough. Okay, so that's where we start. Okay, now we're gonna, I'm gonna keep going until we get this down to 0, but then we'll move in. We'll zoom in so you can make the final measurement. So please, hang on, let me get this. Nope, too much. Too much. Set that back. Okay, now it's moving. All right, now I'm ready to move this little guy. Here, this would be your Meyer scale getting down here. Boop, boop, boop. Ooh. Close. Now you can see why we use digital scales, because this is a little bit slow, but it's a good way to test your knowledge of the major and minor scales. Just gonna wait for it to 0 out. All right, we're pretty close there, okay? It'll settle down. So we're going to zoom in for you to be able to make your final measurement. All right, we've zoomed in now, so you guys are responsible to take this measurement, and we are in grams. If you see down here, right, where's my finger coming in the screen? Right there, right at the very end of this minor scale right there, right? You can see the little G. That's for grams, that's your unit. Okay, we're moving down to station 8 now. You can't see out of your screen here, but we have 100 pennies on the platform, and you're going to again make this mass, take this measurement all on your own. We also wanted to point out that we are pretty close to the 0 mark right here, right? We've got it all lined up, and pay close attention. Look at all 4 scales here, all 4 different slides that we have. And make sure you account for all of them. All right, next we have station 9. It's the thermometer. We've got it in a clamp here, and then we have an Erlenmeyer flask down here. Notice that the thermometer, I don't know if you can see on your screen, is not touching the glass, just touching the liquid. We're measuring the temperature of the liquid. Now we're going to zoom into about this region here to see the red line, and then you can take your major, minor, and uncertainty measurements. Okay, we're continuing with station 9 now. You have to look first to find your unit. I'm not going to tell you. So find your unit, and now we're going to slide down for you to make the measurement. Okay, now hold on. Let us steady it. Okay, the camera is focusing. Okay, you should be able to make your full measurement right now. Okay, folks, this is station 10. For this station, I've enlisted Mr. Ray for some help, so I'm going to be wearing my mask this time. And we're going to start by measuring the length of the desk using our meter stick from here to there. Make sure you use the right side of the meter stick. Hopefully you guys will be able to get in here and actually touch some of this stuff, but one side's got the centimeters, one side's got inches on it, so we're going to ignore that side. All right. Place this here, and oh no! Doesn't reach. Good thing I work in Exeter and we can buy more than one thing. Okay, so now we're going to then add another meter stick. And check, try to be in a straight line. Start, finish. Okay, we're going to zoom in to be able to get your final measurement. All right, here's the start of your measurement. Now bear with us. We're going to slide down to the end. It's white. It's different. Okay. Give the camera a second when we get to the end to adjust. Hang on with your measurement. Alrighty. Don't forget the other meter stick. Take your measurement now. Alright, now we're starting station 11 that we are at. I zoomed in to start here so you can see the unit. So take note of that, and now we're going to zoom out and show you how to operate this. Alright, we've zoomed out here on station 11 the burette to just show you the operation and what the point of this thing is. The burette is just a glass tube here with a valve at the bottom. This is a clamp holding it in place. Okay, so really the tool is really just the glass tubing here. And notice I can control down here. I can have a stream come out or just a drip, real small drip. So it's a nice way to measure volume. And really what's important is what's coming out. Okay, so what we're measuring is where we started and then where we end. That's what's important, is what volume ends up into our Erlenmeyer flask. All right, let me turn that off. Okay, we're going to zoom in now so you can make your measurement of where the liquid was. Don't worry about where we started and we stopped. We're just going to take one measurement here of what the liquid is. Be careful of the scale. The zero, I'm out of frame here, but the zero is up there at the top. Zero is up here. Okay, we're still on station 11, the burette. We've zoomed in now so you can actually take your measurement. You can see there's a nice meniscus there, that darker red section. Please pay attention to which direction the scale is going. Look at the major scale and which direction it is traveling to make your measurement. Okay, good luck. All right, folks, we're at the last station now, station 12, the 1,000 milliliter beaker. There will be one more clip. It's not a station. We just want to show you why we don't use beakers to measure very precisely, but we do use them for estimates. Now be careful on the scale for this one. Do we use the numbers on the left side or on the right side? All right, you can pause the video and make your measurement now. All right, folks, so your lab should be done now. This is not one of the stations, but we just want to show you quickly why we don't use beakers to measure, right? These are really just for containering, right? So you could do a reaction in here, but you're not ever going to actually measure with these. We're always going to use graduated cylinders. Really, it comes down to the uncertainty. The uncertainty on these scales are much greater than the uncertainty in one of these. Okay, so whatever your measurement is, I'm not going to tell you what this was. All right, this is the 400 milliliter beaker from station 6. Okay, so looking at station 6, this is from there. I'm going to take it now, I'm going to pour it into a graduated cylinder and make a measurement and tell you about what you should have gotten when you measure. Spill. Alright, get right down, find the meniscus. Alright, so the uncertainty on this scale is 2 milliliters. So my measurement is 216 milliliters plus or minus 2. Did you get that?